All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to work a number of problems, 5 to be exact, of these fractional distance in one dimension questions. So if you have not already, please watch the other tutorial videos for fractional distance in one dimension. This worksheet here has 5 questions and we'll just work them one at a time, right? So I want you to try these on your own. Don't just go home and watch the video. Y'all need to learn how to do this. But at the same time, I want to offer this tutorial so you don't feel lost. Okay, given point A located at -7 and point C located at +9, find the location of point B if point B lies exactly 4/5 the distance from A to C. All right, so the first thing to do, plot the points. So point A is at -7, so I'll go to -7 on the number line and I'll plot in point A. And I'll just write, so it's big, -7. And that was point A. Point C is located at 9, so we'll go over here to +9 and we'll plot in point C. And that's located at +9. And what we want to find is point B, where point B is 4/5 the distance from A to C. If it had said from C to A, I would have moved my finger this direction, but I'm going to start here and move this way. 4/5 the distance, so we'll almost be to C, somewhere over here. All right, how do we do this? Here's the basic formula. If you want to find the location of point B will be located at the absolute difference between A and C multiplied by the fractional distance, which would be 4/5. And then you would take that product and add it back to point A. Right? So as we go through this process, this little algorithm here will become more clear. I don't really like to put a formula up because it makes you think, well, that's something I've got to memorize. I just made this up. All right? It's not really a formula. So if I want to find point B, first I need to know the total distance between A and C. And that's what I'm calling the absolute distance between A and C, or the absolute difference between A and C. So let's see what that looks like. So that means that point B will be located at, open parentheses, absolute value, and then point A was -7, minus C was 9. You'll see why I put the absolute value bars here in a moment, because let me make sure those don't look like ones, because -7 minus 9 will give me a negative number. There's no such thing as a negative distance, so we want to find the absolute distance. All right, so we'll multiply. Once we get that distance, we're going to need 4/5 of it. So we'll multiply by 4/5. And then when we find what 4/5 of the absolute distance is, we need to add it back to point A so we know how far we've traveled. So we'll add that back to point A, which was -7. Okay? So let's just work with PEMDAS here. And the first thing we need to do is take the absolute value of this difference. So again, B is equal to, open parentheses, absolute value of -7 minus 9 would be -16. So I need the absolute value of -16, which it's going to be +16, but we'll just write it out. So we'll take that times 4/5, and then we can put -7. We're just simplifying this as we go. So now B is equal to, Here I can just say positive 16 because the absolute value of a negative number is a positive. So now I need 16, and I'm going to write this as 16 over 1 because I'm going to be multiplying by a fraction times 4 over 5. All right, and once I get that product, I'm going to subtract 7. But here, a little note, so I need 7 in terms of 5. So I need to multiply 7 by something so it has the denominator of 5. So what times 7 would give me some number that when divided by 5 would be back to 7? Well, if you think about it, that would just be 7 times 5, okay, over 5. And that gives me 35/5, which is just another way of writing 7, all right? But it helps us because now we have a common denominator. So we'll go ahead and in here and subtract 35/5. Just replace the 7 with 35/5. That's all I did. Because remember, this is equal to 7. Okay? Well, we better multiply across the top and across the bottom here inside this parentheses. So now b is equal to 16 times 4, and that should be 64. So now I've got 64. I don't need the parentheses anymore. I've got 64 over 1 times 5 is 5. 64/5 minus 35/5. Now you see why we got that common denominator. So we could do this subtraction. Well, now I need to subtract 35 from 64. So we'll side work here. 64 minus 35. Okay, I'll have to borrow. 14 minus 5 is 9. 5 minus 3 is 2. Okay, so this equals 29/5. Well, now we need to convert into a mixed fraction. Okay, or well, let's do both. Well, we could convert to a mixed fraction, then convert to a decimal. So how many times does 5 go into 29? Well, it goes in 5 times. Okay, leaving behind 4/5. So 5 and 4/5 is what I need. Okay, but what is that as a decimal? Well, 4 divided by 5. Okay, so if you want to find this fraction as a decimal, just take 4 divided by 5, and well, 5 doesn't go into 4, so we automatically have to put in another 0 and a decimal place. Okay, so how many times does 5 go into 40? Well, it goes in 8 times. 8 times 5 is 40, and there's no remainder. Okay, so 0.8, that means that 5 and 4/5 is equal to 5.8. We're almost done. So here is what we must do now. Okay, now we have to plot this point. Okay, so let's go back and find 5.8. Well, it's hard to measure there. That's between 5 and 6. And here's 5.5. So I don't know, about right there, maybe. We'll call it good right there. We'll call this point B, and that would be at 5.8. Okay, if you wanted to check this, you could see if 5.8 was indeed 4/5 the distance between -7 and 9. Okay, so if you wanted to check this, you check this. Remember what the absolute distance was. It was 16. Okay, the absolute distance was 16. So we would take 5.8 and we'd say, does 5.8 really equal question mark really equal 4/5 the distance between those 2 points. So that would be 4/5 times 16. All right, so bring out the big guns here, bring out the calculator just to check. So I'll do alpha y equals and do 4/5, okay, times 16. And I get 64/5, and we'll do math and turn it into a decimal. And that is 12.8. Wait a minute. Okay, yes. Okay, so yes. So here, we're still on track, don't worry. So because of the way I'm doing this. So 5.8 is not, I left out a piece of this. Is 5.8 equal to 4/5 times 16, okay, plus the original value, which would be -7. So plus -7. So without losing a beat here, let's now add -7, right? And what this should equal is 5.8. Ah, there it is. Very good. So we were able to check that. Yes, it does. 5.8 equals 5.8. Check, check. And this is good. Okay. So we've finished problem 1. Okay. On to problem 2. Okay, we're given point D is located at -11. So we'll go ahead and plot that in as we read. That's point D at -11. And point F is at -2. Point F is at -2 right here. We want to know what point E is if E is 2/3 the distance from D to F. All right, so we're just going to go back in here and say, all right, we need point E, and point E is going to be equal to the product of the absolute difference between D and F times 2/3 plus point D. Okay, because we're moving from D to F. So again, complicated looking, we're going to substitute in our values. So point D is -11, and minus point F is -2. So we have here a minus -2. So a minus, minus, minus. All right, we'll fix that here in a moment. So we're going to take the absolute value of that difference and then multiply it by 2/3. Okay, and then we'll add that back to -11. So that's all we've got to do. We'll just keep working it here. And so -11 minus -2 is -11 plus 2. I'll go ahead and write the intermediate steps here. -11 plus 2. Absolute value of that difference times 2/3. And then we can drop the plus minus and do -11. Well, now what? Well, what's -11 plus 2? Well, that would be -9. So I'll put equals, open parentheses, absolute value of -9, okay, times 2/3, close parentheses, minus 11. All right, now what? Well, we're going to multiply. Well, first we'll take the absolute value of -9, which is just 9. Okay, so that'll be equal to 9/1 times 2/3. And once we get that, we will subtract out 11, but again, we want 11 in terms of 3. So we'd say, well, 11 is also equal to 33/3. Okay? So what I did there is I just multiplied 11 by 3/3. All right? So we'll go in here, instead of writing 11, we'll write 33/3, because I know that I'm going to need a common denominator here in a moment. All right, so we can actually multiply across the top here. 9 times 2 is 18, and 1 times 3 is 3. I see now that I could have simplified the fraction even further by canceling the 9 and the 3, but it doesn't matter. So now I've got 18/3 minus 33/3, and something is screaming out at me right now, bro, why don't you just make your life simpler and convert these into whole numbers? Because 18/3 is just 6, and 33/3 is just 11. So let's go back in here and go back to whole numbers. The numbers don't usually work out so neatly. We'll have 6 minus 11. Okay, so what is 6 minus 11? Well, 6 minus 11, what is that anyway? Is it 5? Negative 5. So that's going to be negative 5. All right, so that should be the coordinate, all right? Negative 5 should be the coordinate right here of point E. So let's check. What should this look like? Check. Let's make sure, because we did a lot of math right there. Negative 5 should equal, all right, what should it equal? It should equal 9 times 2/3 minus 11. Okay, we'll double check that. 9 times 2/3 minus 11. Bingo! Negative 5. I love it. What a beautiful confirmation that we're doing this right. Negative 5 is equal to negative 5. Check, check. And that means this is right. So we'll go ahead and put this guy in a little box. And we have point E. Fantastic. That's number 2. See, these aren't that hard. You know, once you get the hang of what you're doing, it's not that hard. Uh-oh. This looks frightening, especially if you're watching this on a small screen. This is just a number line starting at 0 and going all the way to 40. All right. Given point M is located at 22, here that is, I'm going to write it out bigger. This is point M at location 22, and point O at location 39. Okay. I want to find point N if N lies at exactly 1/7 the distance from M to O. All right, so this is starting to become somewhat mundane. N is going to be equal to, open parentheses, open absolute value, M minus O, close the absolute value, multiply by your fraction, which will be 1/7, close parentheses, and then we're going from M to O, so it'll just be plus M. Okay, so let's fill in the blanks, or substitute in the values. That'll be equal to, open parentheses, absolute value, and M is 22, minus 39, close parentheses, times 1/7, close absolute value bar, times 1/7, close parentheses, and then plus M, which would be plus 22. All right, so this is kind of simpler because we're not dealing with so many weird numbers. Now I just need to do 22 minus 39. So 39 minus 22, and the answer will be negative. 9 minus 2 is 7, 3 minus 2 is 1. So negative 17 goes here. Negative 17, la-di-da, times 1/7. And then that will be added to 22. All right, so let's do this inside here. That's just going to be negative 17 absolute value becomes 17, and 17 times 1/7 is, this whole thing just becomes 17 sevenths. Okay, now I need to add 22, but I've got to put 22 in terms of 7. So we need to do 22 times 22 over 1 times 7 over 7. Okay, this is just 22 rewritten. All right, so what is 22 times 7? 2 times 7 is 14, carry the 1. 2 times 7 is 14, plus 1 is 15, 154. So now I'll put plus 154 over 7. So now I'm just going to add across the top 154 plus 17. 4 plus 7 is 11. 5 plus 1 plus 1, that's 7. And 1. So 171. This is equal to 171 sevenths. All right, so you got multiple ways of going about this. I actually think it would be easier to perform the division here. 171 divided by 7. Okay. 7 goes into 17 2 times. 2 times 7 is 14. 17 minus 14 is 3. Bring down the 1. 7 goes into 31 4 times. 4 times 7 is 28. What is that, 3? All right. Put a decimal point, bring down a new 0. 7 goes into 30, I guess again, 4 times. 4 times 7 is 28. All right, and we could keep going, but we don't need to. So that is approximately equal to 24.4. So what we want to do is go locate 24.4, right? That's like halfway between 24 and 25, just a hair less than, maybe about right there. Okay, so this would be point in at 24.4. All right, well, let's double check that. So on our calculator, we want to find 24.4. So that should be equal to 17 times 1/7 plus 22. 171, oh, you can't see any of it, sorry. 171 sevenths, math decimal. There it is, 24.42, and then this was going to continue forever. All right, so we did it correctly. All right, we did it correctly. Good. That's great. So now what? Number 4? All right, in number 4 is going to be a little tricky because it says here we're going to go from V to T. So watch as we do this. Be careful. Given point T is located at -2. This is point T at -2. And point V at 13. Okay, over here, point V is at 13. Find U if U lies 3/4 the distance from V to T. So we're going that away. Watch out, that only affects the way we solve it in a slight way. So we want to find point U. Well, point U is going to be equal to the absolute difference between T and V, right, times the fraction, which is going to be 3/4. And then we're going to add back, well, wait a minute, we're going to subtract, let me think about this. See, this is where it gets tricky. So we're going from V to T. Ah, I know what to do. So this whole thing, I know what to do. This is where it's weird. So once we find this, here's what we're going to do. See if you follow what I'm doing. So I'm going to propose this. I mean, I have no idea. We'll see. U is equal to V minus all this. Okay, so we're going this way. So I say we take 13 and we subtract out this fractional distance. That makes sense. All right, that's kind of neat to do it this backwards way. So we'll see how that works. So point V is 13. This makes sense to me on paper anyway. I could be totally wrong, but we'll see. Doesn't matter. We're just having fun. All right, so now we'll substitute in values for T and V. That'd be -2 minus 13. Absolute value of that difference times 3/4. Yeah, this is making more sense the more I look at it. All right, so now let's just rewrite 13. Oh, I like this problem. It's kind of interesting. Something different. Open parentheses, and then -2 minus 13 is -15, ladies and gentlemen. Okay, so that would be the absolute value of -15 times 3/4. Okay, well, the absolute value of -15 is just 15. So one more step here, we're going to do 13 minus open parentheses. And now we're going to do here 15 over 1 times 3/4. Okay, I don't think I can reduce those fractions at all. Let's just do this. We'll put this equal to, I'm going to rewrite this. I'm running out of room. Okay, so what is 15 times 3? That is 45 over 4. So 13 minus 45 over 4. Now I've got to put 13 in terms of 4. So I'll multiply that by 4 over 4. 13 over 1 by 4 over 4. So 13 is equal to that. 13 times 4. I'm not good at mental math. 13 times 4. Not like my number sense kids can do this in their head, but I can't. And I'm their coach, which should be scary. So 3 times 4 is 12. 4 plus 1 is 52. Okay, so this is equal to 52/4. Alrighty, so we'll just keep solving kind of across here. This is equal to 52/4 minus 45/4. Okay, it's looking good. What is 52 minus 45? Well, it's 7. So this is 7/4. All right, so that's equal to 4 3/4, or 4.75. What do you think about that? So that's where that position should be. Let's see. And it's this way. So, well, follow the math. I mean, I don't know. This could be a total mess. But that's where I think the position is right there. Okay, so I think this is position U. I just got to figure out how to check it. U is 4.75. Okay, so let's see if we're right. Let's double check our work. So if we're right, then that should be 13 minus, 13 minus 45/4. And that's 7/4. Once again, I put it outside the screen. 7/4, which math decimal gives us, oh, I did 4 3/4. Good Lord, I'm sorry. It's very late at night. Sorry, this should be 1 3/4. Good thing we checked. Okay, sorry. You're probably all going, what? Why did he ever write 4 there? This should be 1.75. I'm an idiot. That's why I wrote it there. So, but you know, regular viewers and all students will know that about me already. So let me fix this, a little live edit here. 1.75 should be the point there. That's why we check, folks. So here, this, and even looks better. This should be point U, okay, at 1.75. So sorry about that error. 7/4 is obviously 1 3/4, not 4 3/4. My bad. Okay, so that means we can put this in a box. And we better put this in a box too. All right, so that's the second to the last one, and now the last one. I shouldn't have been waited till I was exhausted to do this, because now we have all this hard stuff. So this is more of a brain teaser one. I want you to solve this. You know, given point Q is located at square root 2, which we can estimate, and point S is located at 2 pi. Find the location of point R if R lies exactly pi over 5, the distance from Q to S. And I say here, keep all values exact. That means don't estimate these as you're doing the work. Only estimate to the 10th place when plotting. All right. So we'll wait to plot values. Okay? Let's just follow the logic. We want point R, and that's going to be equal to, open parentheses, absolute difference between Q and S. Okay? Just like that, times the fraction, which in this case is going to be pi over 5. Okay? And then we'll add that back. We're going from Q to S, so we'll add that back to point Q. So here's what the problem looks like when we substitute in the values. This is going to look scary. Open parentheses, absolute value, and then Q is square root 2, okay, minus S, which is 2 pi. Okay, we want the absolute difference of that, times pi over 5. Okay, and then we want to add that to whatever Q is, which is square root 2. Okay, so that's the problem we have to do. And so if you want to see what this is actually going to look like, without actually trying to solve anything, let's just leave everything in place. So this is equal to, I love this stuff, this is equal to the square root of 2 minus 2 pi. Okay, and we want the absolute value of that. And then this is going to be multiplied by pi, right, over 5. Right, so this whole thing will end up being over 5. This is really the challenge question. And so now I need to do square root 2 with 5 in the denominator, and all we have to do is multiply that by 5/5. So now I'll say plus 5 square root 2 over 5. Okay? And then we can combine it all together in a scary looking math problem. I want to point out one thing. So if I'm taking the square root of 2, which is like 1.14 or something, let's see what it is. So square root 2, 1.412. Right. And 2 pi, if you want to see that, that's 2 pi, 6.28. If I do 2 pi minus square root 2, I can drop the absolute value bars. So I'm just going to switch around the order here. Watch what I mean. So now I'm going to say this. I don't want to run out of room here. This is equal to, this is going to become a distribution problem right now. This will be 2 pi. This is so much fun. I wish I would have done this last year. 2 pi minus square root 2. And that will all be multiplied by pi, which will distribute inside the parentheses here in a minute, plus 5 square root 2 over 5. Look at this problem. I love it. I just love this. Okay? Well, now we're going to distribute the pi inside. We're going to end up with a pi squared. How cool is that? All right, so now we need some more working room. So we'll move this whole problem, okay, over here. So now let's do this distribution. Pi times 2 pi, keep the values exact, is going to be 2 pi squared. Pi times square root 2 is just, so that would be 2 pi squared minus pi square root 2. You'll see why I had you keep it like this here in a moment. Okay, and now the parentheses go away, so it's just plus 5 square root 2 over 5. And we want to now estimate what this value is. This is so cool. All right, so let's go ahead and put it all in. Let's put it in one piece at a time, people. 2 pi squared minus pi times the square root of 2 plus 5 times the square root of 2. Okay? And I guess I should have put all of that in a fraction, right? So I'll just put that in parentheses. Like that. And I'll divide that by 5. Okay, same thing as if I'd done alpha y equals and put this in the numerator and this in the denominator. 4.473. So we'll round to the nearest tenth. 4.5. Cool. So there, what you're saying here is that this is approximately equal to 4.5. All right. All right. So square root 2 is approximately equal to 1.4, and 2 pi is approximately equal to 6.3. 6.28. All right, so now we can plot these points. This is Q, and this is Q, and this is S, and this should be point R. All right, so let's go and plot the points and see if it looks right. So Q is at 1.4, 1.4, about right here. So that would be Q. And that is approximately 1.4. We'll just put square root 2. S is at 2 pi, which is 6.3, about right here. And that would be 2 pi. And so R is at 4.5, which is right here. This is going to be R. And remember, R is equal to this whole thing. So, you know, we could say R is this. And that is approximately 4.5. All right, and so that is that pi over 5 distance. You know, guys, I don't know. I'm not going to stick all this back in the calculator to find out. It was fun to play with this. I was just trying to throw in some of these cool square roots and pi symbols so we could do something a little bit more interesting than just numbers. All right, so that is numbers 1 through 5 of the fractional distance in one dimension geometry homework. Guys, that was fun. I mean, we're starting to get into some stuff here where there's a lot of math involved, but it makes it more interesting. Just wait until we do all of this fun stuff in 2 dimensions. Unbelievable fun coming your way. Thank you so much for being great students, and also for liking this video and subscribing to this channel.